So I'm going to be starting with the free response, question 1, part C. And so in part A we had found the arrows to represent the direction of the velocity vectors. And so in the part C we're finding the direction of the acceleration vectors. And so these are the velocity vectors. And so the acceleration vectors would then be perpendicular to the velocity vectors because as seen in the diagram, it's parabolic motion, or centripetal motion, sorry. And then, so the acceleration vector for this one would have to be like this, because that makes it perpendicular. And then the acceleration vector for this one would be like this, because that would be perpendicular. And originally I had put the acceleration vector going this way, but that wouldn't be correct because the acceleration would then be going inwards and the point wouldn't move in the same way that it is being described. So the next one was question 2 for the free response, and this is originally how I had it, but so it's asking for the shape of the vertical velocity versus time graph as the object is in free fall, and this is as the object is coming off of the disk as it spins. And so the graph would start at 0, since it is free fall. It always starts at 0, and the time would also start at 0. And it would be a straight line because velocity is always a straight line, and the slope would be negative because the object is in free fall. So then move on to the multiple choice. So for number 1, the question is a bowling ball and a sheet of paper are both dropped at the same time from the same height above the ground on Earth in the absence of air resistance, which hits the ground first, and why. So originally I had picked D because the objects I knew would both hit the ground at the same time, but the actual answer was C, in which they both hit the ground at the same time. However, the Earth's gravity pulls with different forces on the two objects, and so that can be shown by the force of gravity equals the mass times the gravity, and gravity is constant, is a constant value on Earth, and on whatever planet it would just be a different value. But the mass of a bowling ball versus a sheet of paper would cause the force of gravity to be different between the two, and so that's why C is correct. So for number 2, an object is moving with a certain speed in a positive x direction, and later the object is moving with the same speed in a negative y direction. And so originally I had been, and the question asks you to find the direction of the average acceleration vector. And so originally I had picked B, which is southeast, because I was thinking that it was a velocity vector as well, but they're asking for the acceleration vector. And so the acceleration vector, since here the object has to stop completely accelerating in the horizontal dimension to then change to the negative y dimension, we know that it has to come to a complete stop. And so the x for acceleration would have to be negative to create the complete stop, and then the y, since the y doesn't change later, it would still be negative y, and so the direction would then be southwest, which is answer D. For number 3, the graph shows the position as a function for time and an object moving along a straight line, during which time is the object at rest. And so originally I had picked D because I thought that A and C were both correct, but the answer is actually B, because the line on the graph there is straight, which means that time, though time keeps moving, the position of the object doesn't change. And so at 1.5 seconds, the position doesn't change, and so that we know that then it is at rest. And so then for number 4, I had actually gotten the correct answer, and Scantron just marked it wrong. So then for number 6, the question is a stone is kicked horizontally from the edge of a cliff. The stone takes 4 seconds to reach the ground and lands 90 meters away from the base of the cliff. Which one of the following is closest to the height of the cliff? And so we know that the T is 4 and A is negative 10 because it's gravity, and V naught is 0 because it has no initial velocity. And so we would use the equation no V of F, which would be y equals V naught T plus 1/2 AT squared, and then we would input the values, and they would then work out to be y equals negative 80, or y is 80 meters above the ground, and that is answer A. So then the next question is question 8. And so for question 8, it says, in traditional coordinate system, the object is speeding up while moving to the left. What signs are the object's velocity and acceleration? So since it's moving to the left, we know that velocity would be a negative, and so since it's speeding up while moving to the left, we know that even though it is accelerating, it would be negative acceleration in the negative direction, because if the velocity is going this way, if we then had the acceleration vector going in the positive direction, that would cause the object to stop motion or slow down motion. And so since it is still speeding up, the acceleration vector would also have to be in the in the negative direction, which is the left direction. Then, so for number 9, a particle is released and undergoes parabolic motion while under the influence of gravitational acceleration. Which of the following best describes the horizontal part of the projectile's motion through its trajectory? So for that one, originally I had picked A, but it's not A because for the particle there are many points of tangency, and so A was the horizontal velocity is always tangent to the parabolic curve, but there are more than one points of tangency, so it can't be that one. And so the answer is C for 9, because by definition, or the answer for C is the horizontal velocity is constant during the entire time the particle is in parabolic motion. And so by definition, horizontal velocity vector is constant. And so the answer is C. The next question is 10. And so this one, it has to do with proportions. So for 10, the answer is D. So the question is, a golf ball is dropped from the height of 80 meters and it takes t seconds to reach the ground. Another golf ball is dropped from a height and takes 2 t seconds to reach the ground. What is the height of the second drop? And so the height, which we'll use y because it's height, equals v naught t plus 1/2 a t squared. And so v naught, since it's free fall and the ball is being dropped, v naught would be 0, and v naught multiplied by whatever t is would be 0, so you can just cross that out as a constant. 1/2 would be a constant because that number is not going to change in the equation, and a would be a constant because it's free fall, so a would be negative 9.8 meters per second squared. So then what you're left with is y, or x if you want to use that value, is constant with t squared, and we know that t in the second situation is 2t, and so what we would do is 2t times 2t, because it's squared, would vary constantly, which with 4t squared would end up being the actual value for this. So for y and 4t squared. And so the original height was 80 meters, and so it would be 80 times 4, which is 320 meters, which is answer D. So the last problem is number 13. And For number 13, a group of students is designing an experiment to verify Earth's free-fall acceleration rate. The experiment will use a projectile launcher to fire a marble at various heights. They plan to measure the distances between the heights. They plan to measure the distances between the initial position and the ground, the time it takes the marble to strike the ground after being fired. Which of the following is the additional measurement that would needed to be able to find the gravitational acceleration using graphical regression analysis? And so for this one, I answered B because I thought they were finding the acceleration using kinematics, like a series of kinematic equations, and so I thought they would need another value to be able to actually find what it would be. But for 13, the answer is actually D. They don't need another because they aren't using a series of kinematic equations. They're using graphical regression analysis to find the value of gravity. And so what it would end up being would be the x value that they collected and the t value that they collected, and they would use that to create a scatter plot. And using like a computer program or something, they would create a line of best fit, and they would find the equation for that line, and then using the first term they would multiply that by 2 and find the value of gravity. And so no additional information is actually needed for this.